not really. So Sarah, welcome to the DevOps Days MCs Get Slap Happy afternoon.
Thanks for having me. And thanks to everybody who has been working really hard to make this happen. It's been definitely a lot of interesting time and a lot of talks and conferences that we were looking forward to and they canceled. So the fact that we're here today and everybody's working really hard to make it happen is really amazing.
So I come around and say, like, one of the things I really love about your talk is it is so, what I love and also found frustrating as someone who was trying to come up with questions and stuff is it is incredibly dense. There is so much material in that, which is fantastic, and I feel like I need to watch it many times, and it's great because it's been recorded. But one thing that, someone in the chat brought this up, but I'd like to kind of run into it a little bit to think about is, like, thinking about, you kind of talking, like, think about Mosh Pit as a study of managing complex systems, right? So he says, there's a ton of individual actors doing whatever they want, but with clear rules, like, nobody gets hurt that doesn't want to, and make sure everybody leaves with their glasses intact, right? That are strongly enforced. So, like, when you think about that when we think about complex systems that have those places and where those things go in, maybe we could kind of talk about that for a little bit, about expanding upon how that, I don't even want to say metaphor, because it's not really a metaphor, it literally is one of those things, right?
It sure is. Yeah, I think it's interesting because when I was originally thinking about these examples, my husband, Bobby, he brought up that I used to go to mosh pits. Yeah. I'm like, what? So I'm more of a person who sits back and like analyze things like, is that safe? Where is the origin? What do people think? Do I belong there? So I sometimes do overanalyze things, but he was just like, yeah, there's so much fun. And I look at it, I'm like, what are you thinking? Like, were you thinking to be in there? So I think like that was a really great example because as you mentioned, like people collectively move together, right? But there's no really thinking behind it. There's no pattern behind it. And no matter what you do, you can't exactly repeat those patterns and see the outcome, right? It really is at the time and really look at the movements of the crowd. But it also is the interesting about it is that when you're in the mosh pit, you're not thinking, you're just moving with the crowd. The great example of this is when I mentioned, Jesse Silverberg, he used to be going to these mosh pits. And then one day he was standing behind and looking at it from far. And he's just like, this is collective behavior. And he had just learned it a couple weeks before. So he went back and he built a model to model this mosh pit and this collective behavior and see how things interact with each other and therefore not exactly predict, but see some of those movements.
That reminds me of, have you read Team of Teams?
I have not.
It's one of those good organizational books, but I'm gonna mess this up. It's complex versus something that is complicated. Yeah.
Yes.
Complicated, you can break it apart into little pieces. Mm-hmm. And you know how something works. Like a bicycle, it has a lot of parts, but you put them together and you know how it works. Complex, they use the pool example. You shoot a pool ball into the number of however many you queue up. And you can't predict how it turns out. That's complex. Just like a mosh pit, like you can't really recreate it perfectly every time.
And it has a lot of moving parts.
Yes.
So you have to really break it out and really understand how each piece works and what's the intent behind each of those.
And I think that's the thing, like, again, thinking about complex systems, there are things that are happening individually, but still within some quote unquote agreed upon rules, right? And the same thing, so like Aaron said in the chat, there are these rules, and it's not like you sit down and discuss them at the beginning of the concerts, but it's just sort of this known that it's like nobody gets hurt that doesn't want to get hurt, right? It's like we take care, and you're working within these boundaries, but they're not formal boundaries. They're just sort of intrinsic boundaries and rules. And I think that's the thing with complex systems is, again, like, in fact, a complicated system has defined, understood, quote unquote, rules, right? A complex system, they're not really defined that way.
Yeah.
And it's really hard when you talk about this complex system. It's very hard to really put it in words or build a model out of it, because again, like all models are wrong. So the best thing you can do is to build something take it out there, test it, observe it, see how it behaves in the environment, bring it back and test it again in order to make it better and better. So yeah, I think like even with Moshpit, I'm thinking like I'm definitely a person who think about rules and try to predict things. Putting me in the middle of Moshpit, I will be squashed within like 5 minutes because I'm trying to look around and see where should I go. So therefore, I personally will not survive there. But.
Well, and I think that's the thing with complex systems, and when this comes in, is it's where our prefrontal cortex like kind of works against us because we want pattern recognition. We want simple things. When we think about complex systems, we want it to be that if we turn this dial, it will fix this thing, it will change this thing. But it's really it's all the contributing factors, it's all the layers of all those pieces. And that's contradictory, like I said, it's hard to put in words because it is fundamentally contradictory with how our literal actual brains work, right? Like our survival is because of finding those patterns and all that. That's how we evolved to survive when we were, trying to like eat fruit and not get eaten by tigers and stuff. But now we're trying to solve global warming and all this other stuff. And it turns out our brains are still trying to like not get eaten by tigers, which is run away from tiger, problem solved, right? Don't be where tigers are. It's like how you, so.
Yeah, and I think one thing that's really important in computational thinking is the ability to make predictions and to be able to build a model to really test out your predictions. There are, I guess, 2 times of really programming or in our field. There are times that we're just learning. So what is this API event is, what does it do? What are these data set even telling me? And there are times that we have some clues about our data and we want to make some sort of prediction. So, just thinking computationally about pieces and have some ideas about what our goal is, that gives us ability to build some model and test that and basically just evaluate our assumptions. Were we correct? Where did we get it wrong? And do we need a bigger data set? And also be able to share that with everybody. So I think that's really one thing that if I want people to take something with them is the ability to really think deep about building their models and making predictions. And sometimes you all get a little bit lazy and push a lot of these modeling and testing stuff to the last minute that we need. But the fact is, these days it's just so easy to do that, and I encourage everybody to think about those things well ahead of the time.
I think about it every Wednesday in the morning, every other Wednesday in the morning when it is our sprint retro, and I realized that we were really bad at predicting our points for that sprint, and we're like, oh man, we are really consistent, but really not accurate.
Consistently wrong.
Yes. Humans are not good at predicting, turns out.
Well, that's because we don't have crystal ball. Like, I think that's sort of the thing with that part is like that, kind of cognitive distortion of like fortune telling, right? Literally, which is like if we only had enough data, we could predict, we can look for likely outcomes. But that's sort of the problem. And then we could go down a whole other thing that Margaret just opened up. But like, that's a whole, like all the story pointing, like just so we can all agree, that's just all fiction, right? Like those are lies we tell ourselves so that we like feel better about what we're doing. But like at any point that someone could say, with what I know at this point, I can tell you anything other than hard or not hard.
Yeah.
But I think so here's the problem, and I don't want to go all the way down this path, but like if you look at what that stuff was intended for at first, it was just to get you to have a feel about it. But it's now turned into a measure, right? Of like, and if you don't like, put it this way, if you think about the way that story pointing and stuff intended, it was like totally fine if you were wrong. Like now you learned, now you got better, but now it's like, but wait a minute, Margaret, you said it was 8 points. Why isn't it done? I don't even remember the Fibonacci anyway to do it.
Fibonacci was in my last example.
Yes, it is.
Oh, it is one, okay.
But like, how many hours is that?
Right.
No,
Yeah.
it's 8 points. Sorry.
No, this is actually a hot topic for me because I just joined a company as an interim CTO. So a lot of these things we have to put in place, and their team is exceptional. They're amazing. They're adopting. We're a very small team, so trying to figure out some processes so we can communicate these decisions. And I think when it comes to story point, to me, it doesn't really matter unless there's a stakeholder sitting on the other side that needs some predictions, right? Aside from that, the stories are in the backlog and you have to deliver what has to get delivered. And I think the review of that makes people a little bit at ease, just to pick up a little bit ahead of the time, knowing what's coming, put your questions in, and think about how you want to approach building it. What data do you need to collect? What predictions do you need to put in place? Like, those are the things that I very much value when it comes to sprint and sprint planning and things like that.
Well, and I think that's the thing. I think when you're using it as a tool for committing to a reasonable amount of work, it's fine, but it's not a number unto itself of your success, right?
Exactly.
So because what happens then is it's like, well, we just start sandbagging or whatever. Like,
Exactly.
we'll find a way to make our points, but that doesn't do you any
Tickets
good.
closed
Right?
means I
you're
open a
like,
bunch more and close
right.
them.
Yeah, and so, but if it's to sort of say like, okay, I can take on a reasonable amount of effort, and the reality is if it turned out it was bigger than you thought it was, it shouldn't be, while you suck at predicting, it should be like, ooh, well, that was uncomfortable, but what do you learn from it, right? And this is going all the way back to, we just talked with Dr. Cook about, right? It's like, how are we learning from these things? How are we becoming, but that's the problem, is all this measurement is not about learning. It's about, showing activity, right? So
then there's the other measurement too, like the models that you talk about, which is not just input out, input in. It's a little bit more computational.
Right. And, it's just a matter of really learning and thinking and, just predicting how this is going to behave in the real world. A good example of this was at election time, right, in around February, when everything fell apart.
I don't know if you noticed what happened.
I had to bring it up if this was in my previous talk, but we're software engineers. We can predict what went wrong. Somebody didn't test their stuff. Somebody maybe didn't test this with real users. So as software engineers, we can make predictions that, hey, if I was on that project, I would probably do these things and things would go better. It's easy for us to say it. For other people, that's not a bug, that's a feature. And I think that when it comes to you as a software engineer and somebody who really makes those decisions, you have to be prepared to answer those. You have to really put your work that, did I actually put a lot of tests and something unexpectedly happened that, it broke in a real environment? Or did I completely just skip testing because I had to meet my story points at the end of the sprint?
Yes.
So we have a question came in from the chat, and I would love to talk about this one and see what you have to say. But so the question is, how is computational thinking different than the scientific method?
I think with the scientific, computational thinking, again, it applies it in many, many things, right? A quick example of this, actually, my kids are in first grade and third grade. And a couple of years ago, I went to school. They have a program that parents go in and talk about their work. So I went in and was like, all right, should I teach you about C and C++ or Clojure? Let me think about it. So my goal was just maybe I teach them a little bit about how to think, how to approach the problem with a new tool. So, of course, my kids are stuck with 2 engineer parents. They have no other way to learn a lot of these algorithms and bucket sorting and bubble sorting and all of that. So I put a little activity together, went to school. And I gave the kids, cards. I took a deck of cards. There were 20 kids. So I just gave them a few cards, asked them to sort it as fast as they can. Obviously, the first thing they thought is to, look for a 1 and a 2 and a 3. And then we realized, okay, this is as you grow the deck, this is gonna take a lot of time. So how about we break it the work? How about each of you get 5 buckets or 5 cards, and then we put buckets 1 through 10, 10 through 20. And then you run around and actually put your cards in the correct bucket. And then you take that bucket with your team member and sort it. So we broke the idea and basically broke it down and fixed the problem. And then we put together, and within 5 minutes, we sorted all the cards that we wanted to. So to teach them how to approach a problem, hey, I know that bubble sort is your instinct, but how about if I teach you a new thing? Does that make your life different? Does that help you looking at the problem a little bit differently when you go home? So that was my goal. And lo and behold, the next day, the teacher sent me a message and said that today the kids were writing about Martin Luther King. And they came up with the idea because of yesterday that they wanted to put buckets on the table. And we're talking about 6-year-olds. They came up with the idea about putting buckets on the table with topics. And each child like put their papers in the proper bucket, and therefore they have their index and they put their book together. So with that 5 minutes of exercise to give these kids new tools, a lot of them thought about it next day and thought about, how do I solve this problem that I have like 100 pages of papers? How do I organize them? I think that's the point. I think with the computational thinking is really helping everybody to think about their tools and how they're using the tools, how are they documenting, how are they really transferring that knowledge to the rest of the group is extremely important.
I think that's a really good point to bring in, which is it's not really a process, right? It's a reframing, it's an approach, and it's having then that, where does that impact how that work happens, and not because you knew a new process, but having that other perspective is kind of firing the neurons a little bit different to see how this could apply, right? Because that's those intuitive leaps, like, which is the example you gave, which was nobody told those 6-year-olds that like you could sort things the same way you did the cards. They made that leap because that's what we do with our human brain, right? But you have to have something to connect, right? And be willing to do that.
Yeah, like if you've, I thought of an escape room I did with a group of friends, and like a lot of them are architects, real architects, as they like to say. And I could tell they all thought kind of similarly. And then we had one friend who is a brewer, and it was just, his perspective was so different. Like one was like, line up the things and look at the shadow. The shadow spelled something, and everyone was trying to make them the same height. It was like, oh no, look at it from total different perspective. It's just that
It's
that
as if having diverse backgrounds and experiences might make teams stronger or something crazy
wow,
like that.
that's crazy.
Right? Yeah. Who knew? What do you think, as you because you spent a lot of time talking about this. This is kind of where what's the thing that you think usually surprises people when you're having conversations around this approach?
A lot of time that they're thinking computationally, but they don't really know that they're doing it. A lot of time, like you choose your tools for a reason, or you have a process, you have an algorithm running your head every time you do something. But when you a lot of time when you point at them that, hey, you are actually thinking computationally, you have an algorithm running in your head, it's like that common sense that's not so common. Like you have to tell people, hey, you're actually doing it, so don't be afraid of it. I think that's one thing that's interesting, that it comes often. People are just thinking that computational thinking and these buzzwords belong to people who are good with math, and they're computer scientists, and they know how to break a computer apart and put it together and work even better. But the fact is that's not true. I think all of us, we're at the point, I think one point in my talk was just that, with the interface that we have right now and the programming language that we are using right now, you don't need to have that deep understanding of operating system in order to do anything. A teacher or a physics professor or physics student, they can open up a new Jupyter notebook and literally write few lines of code to test their ideas. And those are people who I call them power users. You don't need to understand any library deep to understand exactly how it works. You just want to run a couple data and get some ideas. Feel free to just copy paste and just get your ideas and see how it works. I think that's something that's very important, and the encouragement that tell people just take advantage of it. That's not running your ideas and testing your ideas and sharing them with everyone around. It's so easy. Like, take advantage of it and don't just push everything to the last minute.
That's very close to Emily's growth mindset that she mentioned earlier, and math as the example too.
It's like it all comes together.
Yeah.
Like we built a program. Maybe.
Whoa.
Note, we did this on accident. But that being, Sarah, thank you for an amazing talk. A great chat. This has been definitely stretching the mind. Hope we're shaking off, doing some thoughts there. But